whatever they did to one of the photons in one location, in one moment in time, the other photon acted like it was having exactly the same experience at exactly the same moment in time. The matrix is the release. The Big Bang is the matrix. It's emerging as itself into itself. All of these things, they're only possible because something exists in the nothing, because something fills the space of the universe. Well, the scientific community is beginning to describe a structure that sounds very similar to the Hopi web and to Indra's net. It's a structure that underlies our everyday reality. And even Einstein sensed that this structure was there, although as a scientist, interestingly, he shared it from a very poetic description. What Einstein said to us, he said, nature shows us only the tail of the lion. He says, I do not doubt that the lion belongs to the tail, even though he cannot at once reveal himself because of his enormous size. So what Einstein was saying, from his perspective, is there's something out there. It's so big, but we cannot see it from our vantage point where we are in space and time. And this underlying thinking played a powerful role as he developed his theories of relativity and some of the other theories and mathematic concepts that led to those theories. So there's a common theme that weaves its way through each of these descriptions, through the web of spider grandmother, through the net of the god Indra, and through Einstein's perspective, this idea that there is something out there that connects all things. Well, in the beginning of this program, I shared Max Planck's statement, his perspective of this essence as well, and Planck's statement of this matrix that underlies our physical reality is a perfect example of what this thinking is all about. So the question is, what is this made of? What is the web or the net or the matrix made of? And what are the rules that govern this fundamental field of energy, and what does it mean to us in our lives? Well, in season 1 of Missing Links, the 5th episode, I described an experiment. It's performed in Switzerland at the University of Geneva in 1997. I'm going to summarize the experiment for you now, and I'm going to do it from a little bit different perspective, with a little bit different emphasis from what I did in that first season. The experiment itself, it was no secret. It was reported to over 3,400 journalists, educators, scientists, and engineers in more than 40 different countries. And the experiment simply goes like this. Scientists took a photon, a particle of light. This is the stuff that atoms are made of. They took a single photon. They wanted to create 2 identical photons, so they took the one and broke it into 2 separate photons so that each one would have identical properties. And those 2 photons, they isolated into a chamber, and from this chamber they used fiber optic cables moving in opposite directions, and one cable went 7 miles to a town 7 miles away. The other cable went 7 miles to another town 7 miles away. From the place where these photons began, each of the photons was shot 7 miles in opposite directions, so when they reached their targets, they were 14 miles apart. And this is where the experiments actually began. Because what the scientists found was whatever they did to one of the photons in one location, in one moment in time, the other photon acted like it was having exactly the same experience at exactly the same moment in time. They used atomic clocks to tell them how long it took, how much time did it take for the information to move from one photon to the other. And this is where the problems began, because the atomic clock said the time was 0. There was no lag time. It was instantaneous. This breaks the rules of Einstein's theory of relativity. Relativity says that nothing can travel faster than the speed of light. For the 2 photons to have exactly the same experience at exactly the same time with no lag time means that somehow the information had to move from point A to point B instantaneously, faster than the speed of light. This is where the problems began. So the behavior of the photons is a problem for conventional physics. Those protons are defying the laws of conventional physics. However, they conform to the laws of relativity. And this is where the experiment becomes very relevant to everything that we're talking about when we talk about this matrix of energy. What the experiment tells us is that particles that are once joined physically remain linked energetically, even though they are physically separated from one another. Two photons were once a single photon. Even though they were split into two separate photons, energetically, they were connected. The term is called entanglement, quantum entanglement. And what it means is that whatever is happening to one of those photons in one place, whether it's 14 miles from the other one, on the other side of the planet, or on the other side of the universe, is irrelevant. They are entangled, and they will always reflect the exact same parameters in one that are happening to the other. Let me tell you why this is so powerful, why this is so important. If we think about the model of creation, if we think about our universe, scientists tell us that the universe began with a tremendous release, a primal release of energy that we call the Big Bang. In the Big Bang, energy was released and it began to expand, and physical matter began to expand and move away from the point of the release of the energy. If we could reverse the Big Bang, if we could take that physical matter and bring it all back to the point where it all began, what scientists tell us is at that moment, just after the release of energy, all the matter in the universe, as big as the universe appears, all that matter would fit into the space about the size of a single green pea. That all of the physical matter from all of the bodies, all of the planets, all of the stars, all of that physical matter, which is believed to take up only about 4% of the whole universe. Scientists tell us 96% of the matter is missing. 96% of our universe they believe is empty. So that 4% would be compacted into a single sphere about the size of a green pea, a really hot single sphere. They tell us about 18 billion million degrees. And when I talk to the scientists about that, I said, now how do you really know that? And they say, well, we don't. They say, but we know that it was really hot. So when all of that matter was compressed into that single green pea, here's the key. Everything was connected. Everything was connected. And even though the force of that primal release has allowed the universe to expand, and it's expanding today, and the physical matter is no longer physical connected, the experiment that we saw with the twin photons suggests that all physical matter is still connected, that we are still connected to one another. We're connected to our planet. We're connected to other stars and other planets. This is the power of understanding what the matrix is all about. The key is that the matrix is not a byproduct that happened after the Big Bang. Now, let me say this again. The matrix that we're talking about, it's not something that happened after the primal release. The matrix is the release. The Big Bang is the matrix. It's emerging as itself into itself. Now, the implications of what I'm saying to you and what these experiments are showing are mind-boggling. We're going to explore them throughout this series. But I really want to emphasize that the field that connects all things, the web, the net, Planck's matrix, the divine matrix, this field, it is the release of energy itself. Where did the field come from? Well, it depends on who you talk to. The ancient Vedas, for example, over 7,000 years before present, they offer us a clue. It's not in science, but they describe a time before the beginning when what they call is Brahman, the unborn, in whom all existing things abide, the one manifesting as the many, the formless, putting on forms. This is the way the Rig Veda describes this primal energy that is happening as this release of energy that we call the Big Bang. So what we're finding is that the field that fills the empty space, this 96% of the universe that is believed to be missing, it's not missing at all. It is a form of energy that's been with us from the very beginning. And this is why I think this is so important. And cosmologists at the University of California in Santa Cruz agrees. What he says is that the Big Bang did not occur somewhere in space, but it occupied the whole of space. The Big Bang was space itself, bursting into a new kind of energy. And that's the end of the quote from him. So with these ideas in mind, let's go back to that twin photon experiment. What really happened? Two photons, 14 miles apart, having exactly the same experience at exactly the same period of time. How did the information get from one to the other? Well, that's a trick question, because now we know it didn't. It didn't have to get from one to the other because the information was already there. And this is the point. This is the controversy. This is the mystery. It didn't need to travel at all. It was already present. The experiment is telling us that we are still connected to people and places, no matter where in the universe, where on the planet they may be. This is why intuition works the way it works between a mother and her son, for example, in a battlefield halfway around the world. We'll see this in future episodes. This is why remote viewing works, that we just saw in this episode. This is why experiments in teleportation are working. Russell Targ, the co-founder of the Cognitive Sciences program at Stanford Research Institute, Menlo Park, California, he describes this connection in a really beautiful way. Listen to what he says. Russell Targ says, "We live in a non-local world where things physically separated from one another can nonetheless be an instantaneous communication." That's the end of the quote. Well, the Big Bang and the twin photon experiment tells us why Targ's statement is so powerful, why it's so true. In 2004, physicists from Germany and China and Austria reported the first successful experiment with teleportation of quantum information. The results are out there for everyone to see. They're reported in the very prestigious journal Nature, volume 430 in the year 2004. And what they did was they teleported the blueprint for quantum particles from one place to another, and they did it successfully. This was the first step. Huge implications now in data encryption and data security and information transfer, and ultimately the quantum transfer of stuff like you and me. So all the things that I'm talking to you about right now, all of these things, they're only possible because something exists in the nothing, because something fills the space of the universe. So as excited as the scientists are about the twin photon experiment, about the teleportation experiment, in the excitement of reporting the strangeness of the outcomes, I sense that they may be missing the most significant part of those experiments, what those experiments are telling us. They may be missing the most shattering implications, because for all of these experiments to work, it means that they must be happening within something. We're coming back to the same question. What is the stuff that makes these experiments possible? We know it's a field, but what is it really? What is it made of? How does it work? Well, in a makeshift laboratory, hidden in the basement of a Case Western Reserve University building in Cleveland, Ohio, 100 years ago, two scientists performed the first experiment that was supposed to answer this question once and for all.